Welcome to another episode of Code for Thought ByteSized RSE, sponsored by the Universe HPC program. But first of all, a Happy New Year and all the best for 2025. And also welcome to a new season of Code for Thought, the show for researchers who write software, scientists who code, and those of you who work as research software engineers. And as you've just heard, this season starts with a ByteSized RSE episode. For those of you who heard of it for the first time, here is what ByteSized RSE is. The concept is a short online course on a specific software engineering subject that will help you, or so we hope, in your daily work. The online courses are usually an hour long and focus on practical exercises, like for instance how to use version control systems, which seems to be very popular, or how to get started with software testing. And since the online courses have limited spaces, Code for Thought provides a companion podcast episode that is accessible to anyone who wants to listen to it and catch up on the material. And for this ByteSized RSE class, we focus on something that plays a vital part in understanding, managing, and communicating research data and scientific results. I am talking about visualizing data. And helping you with that is Kirsty Pringle from the Software Sustainability Institute, and you will hear from Kirsty a little bit later. But for now, let's get started. They say a picture says 1,000 words. And indeed we use images and visual symbols all the time in our daily lives. And research and science are, of course, no exception. Ever since the rise of scientific publishing in the 18th century, scientists have drawn charts, bars, graphs, and lines. Of course, for a long time, we had no computers, and all of the graphs and charts were drawn by hand. And during my university days in the 1980s, we drew graphs and charts from experimental data, including error bars, for instance, using linear or logarithmic graph papers. And of course, there are still researchers who are quite happy to use paper and a sharp pencil and draw graphs and histograms by hand. But this being the 21st century, it's far more likely that you'll be using a computer to do that. Certainly when it comes to writing a scientific paper, preparing for a presentation, or for instance doing your thesis. And this isn't just a question of convenience. For large data samples, it is often the only practical solution to do any meaningful data analysis and data presentation. Luckily, there is a plethora of tools available to show and present your data today. A number of them come ready-made in big Office application packages, such as spreadsheets. Others are libraries that you can use in your code to generate a pie chart, for instance, or a histogram. In Python, for instance, a very popular package to turn data into images is the matplotlib library. Matplotlib was developed by a neurobiologist called John Hunter from the US and released for the first time in 2003. And since then, it's gained a strong following amongst Python engineers. Python is not the only language that has libraries like matplotlib. For all of you using JavaScript, for instance, there's a library called D3. That is the letter D and the number 3. And of course there's a lot more in other languages as well. Then of course there are situations where general purpose libraries or applications won't do, and you need a bespoke solution. Applications are libraries tailored to specific domains and fields in research. During my time in particle physics, we used software created by CERN, the International Particle Physics Lab near Geneva in Switzerland, that helped us produce histograms and specialized plots to analyze our physics data. Maybe the field you're working in has some specialized tools to present data as well. But having the tool with all its bells and whistles is only half the battle, really. You still need to decide how you want to present your data and what the story is you want to tell and what you hope your colleagues or anyone reading and seeing this will take away from it. After all, the best plots or the most sophisticated histogram are of little use if it makes people scratch their heads and wonder what on earth it all means. As I said at the beginning, pictures say 1,000 words, but it's up to you that these words make actually sense. Designers and engineers have been thinking about the principles of data visualization for a long time, and in the next section, I'd like to present you some of their ideas. The word Gestalt is a German word meaning form or shape. It's also a term that was coined in the early parts of the 20th century by a group of Austrian and German psychologists. I need to be careful to summarize Gestalt psychology as I'm not a psychologist myself, but it appears to be a theory of human perception that takes a holistic view, meaning it looks at how we process entire patterns and not just the individual bits these patterns are made of. It's summarized perhaps in the phrase, "The whole is other than the sum of its parts." You probably think you've heard that before, haven't you? But I hazard a guess. What you're probably thinking of is, the whole is bigger than the sum of its parts. Which, if you look closely, is not quite the same. In the Gestalt framework, the whole is something that could be different and perhaps even completely unrelated to the individual parts themselves and the sum of them. But now you may be thinking, well, that's all very interesting for sure, but what on earth does that have to do with data visualization? So let's look at some examples. Some of you may be familiar with images showing optical illusions. That is, we perceive something in the image that actually isn't there, or not what we think is there. For instance, this. Two lines parallel to each other. Both lines have arrows at either end, but for one line the arrows point away from the line, and for the second line they point inwards. Most people will answer the question whether the two lines have the same length with a no, because one of them will appear shorter, and I'll leave you to it which one that is. There are plenty of examples like this, for instance the so-called ponzo illusion. The fact is that our brain doesn't just take the data it receives from our eyes as they come in. Our brain interprets and puts the data points into context. And this perception and how it can be fooled by optical illusions is what Gestalt psychologists have been working on. There are a number of principles in Gestalt psychology, and there's actually an extensive Wikipedia link on the subject, which I encourage you to look at, and you can find that in the episode notes. The online class that some of you may have attended listed 7 principles, and here they are: similarity, proximity, common region, continuation, closure, symmetry and order, and finally, figure and ground. Unfortunately, once I started looking around for these terms, I found that other sites use slightly different terminology and sometimes group principles together. So you may find the same principles under different names depending on where you look. But let's stick with the ones I just mentioned for now. I'm not going through all of them in great detail, but let's focus on one. Take, for example, the principle of closure. Imagine that you have a circle. When we think of a circle, we think of a continuous line with a fixed radius. But what if you use a dashed line? Our brain would still see a circle. Even though, strictly speaking, instead of one continuous line running in a circle, you have a set of short strokes with gaps in between. But brains, it appears, don't like unresolved shapes with lots of gaps in between them. We love to see entire shapes. And so we fill the gaps, or rather our brain does, and still are able to perceive a circle. Common region is another interesting principle. Let's say you have a rectangle filled with rows of little squares that have the same distance to each other and the same color, so that when you look at it, it just looks like a page filled with square blobs, except when you have one region of the squares with a different background color. Our attention is then immediately drawn to this particular group of squares. And this is something we almost instinctively use in our presentations. Lines that are dashed, tables where one column has a different background color than the one next to it. We use the ability of our brain to perceive shapes, to group elements together in order not to only show the raw data, but also to let the viewer know what the data mean and how they should interpret them. In short, We use all these little tricks and optical illusions so we can tell a story. And talking of story, I think it's time for someone else to continue it. Meet Kirsty Pringle from the Software Sustainability Institute. I met Kirsty at the Research Software Engineering Conference in Newcastle in the UK in September 2024. Kirsty presented a poster for a study she did with others on air pollution. Air pollution is indeed a complex subject with different important components. How can you make sense of this and show a graph to readers and viewers that will tell them what the levels of air pollution is in their area? A designer challenge for sure, and here Kirsty tells us how she went about it.
My name is Kirsty Pringle. I'm project manager of the Software Sustainability Institute. Before I joined the Software Sustainability Institute, I was an atmospheric scientist and a research software engineer.
And you went to the RSE conference last year in Newcastle, 24, where you gave it was a poster, wasn't it?
It was, yes.
It was a poster about environmental issues, but let me not talk about it. I would like you to describe what the poster was about.
Sure. So the poster basically summarised the work that we've been doing. It's called the Air Quality Stripes Project. So the idea behind it is basically a kind of slight copycat of the climate or the warming stripes developed by Ed Hawkins, the University of Reading, in which he's shown the global mean change in temperature as a series of blue and red vertical bars. And what the warming stripes really very clearly demonstrate is that the planet is getting hotter. It shows the change in temperature from, I think, 1850 up to present day. And we were really inspired by that image because it's really created conversations. It's engaged a very wide range of people on quite a complex topic. And it's really clearly demonstrated just the extent to which the planet is warming. My colleague, Jim McQuaid at the University of Leeds, he came up with the idea for air quality stripes, basically to kind of draw on my background as an atmospheric scientist and as a RSE to see whether we could kind of take data, existing model data, to plot up the change in air pollution in lots of different cities around the world. So we did that using a combination of model data and satellite data and tried to make the images kind of fairly easy to understand and fairly engaging.
Air pollution can be actually quite a complex thing. There are a lot of data points in there, and there are lots of factors that play into the air pollution. There's the ppm, I can't remember now what it stands for. Then there is, of course, the various different noxious gases.
Yeah.
So it's complex data that you have to display. So how did you go about designing and deciding how you want to display the data?
So the first thing we did is we simplified the problem that we were looking at. You're right, there's lots of different types of air pollutants, and the air pollutants have changed in different ways. The different types of pollutants have changed in different ways. So we made the decision to just focus on one particular type of pollutant. So we focus on particulate matter, so PM2.5. We made that decision because PM2.5 is one of the most important pollutants in terms of the effects on human health. So the first thing we did in terms of simplification was just make the problem easier by just looking at one thing. The other thing we did in terms of visualization is that air pollution is often considered kind of at a regional level or a countrywide level. What we did is we kind of decided to focus on the city level. And I think that's one of the reasons why the project's been fairly popular, is because people are able to kind of really hone in into an area that they know. So we did stripes for London, for Edinburgh, for different cities throughout the world as well. So people are able to identify quite closely with the locations that we've chosen. In terms of visualization of the data, what we did is we went through a really extensive period of asking our colleagues, our friends, our family. We did it quite informally, and we have a paper actually in discussion at the moment in geoscience communication about this. And one thing we say in the paper is that if we were to do it again, we would do it more formally, this feedback stage. But we got such useful feedback from asking people. So, for example, one of the things we did is we presented data and we put, a number like 10 micrograms per meter cube, 20 micrograms. But then we got a lot of feedback that said, I don't know what this means. Is this good or is this bad? And so we made the decision to create a second series of plots, which also had kind of indicative levels, which kind of very good, which made them much easier to interpret. So we were able to provide people with the actual numbers if they were interested in looking at it, but then also kind of indicative levels. And that made it easier for people to understand. Another thing that came from that process is the climate stripes are famous in the fact that they don't have any numbers on the plots at all.
Indeed, yeah.
But we felt that we needed some numbers because what we have, unfortunately, in the climate, we've got a global warming trend. It's a single trend across the whole globe. But the great news about air pollution is that you've got some areas where the air pollution is getting worse. You've also got a lot of areas where the air pollution is getting better. So we have differing trends, which is just a wee bit more complicated than the message that the climate stripes, the warming stripes are trying to convey. So we added a trend line and we added numbers. We did this because people didn't understand it without it. As when we asked around, we felt that overwhelmingly the people we asked said they preferred the version with numbers and with the trend line because they were able to understand it a bit more easily. People have to understand data. Everyone's very busy, so people have to understand your plots. If you want it to go out to the public, people have to understand it very, very quickly. If you can make that as easy as possible very quickly, then that's advantageous. You don't want too much data, too many numbers, because that gets confusing, but you need the right amount. I think one way to find out the right amount is really just to ask around and to kind of go to your target audience and say, does this make sense? Does this not make sense?
How many drafts did you actually go through before you homed in on the design? Are you in a position to tell?
Do you know what? We have a joke that it took us about a day to kind of analyze the data and about 3 months to decide on the color scheme. It
really?
a long time. The design of the graphs is quite easy because we kind of copied the warming stripes, but the color scheme is very, very hard. The warming stripes have this kind of intuitive color scheme where you've got blue's cold, red is hot. Air pollution doesn't really have that. So a lot of air pollution communication in terms of the public understanding is done through a traffic light scheme. Often you get like green for good, red for bad. Yeah. It's not great for people that are colorblind. We started off doing that, but it's actually not very intuitive when you understand it. And so we worked with a visual designer, a guy called Ethan Brain, who's based in the States. And what he did is he analysed lots of Google images of air pollution. So he basically kind of did a Google image search for air pollution, and then he analysed the dominant colour palettes within that. And he basically found that images associated with high levels of pollution had a kind of reddy, darky brown colour to them, and lower levels of air pollution kind of yellowy colour, and clean air obviously is blue, sky is blue. So using this data, he basically came up with a colour palette for us, which we tweaked. It also has to be intuitive to understand in terms of you want an equal spacing or a good gradient spacing between the different colours. But the broad colour palette came from these Google image searches, which was really useful because it felt that we were grounding the colour in some kind of truth, which hopefully made it a bit more intuitive to understand.
I think the color scheme is quite important. I mean, in a number of plots nowadays, because you can actually add additional information. Let's say you have a two-dimensional plots with two variables, but then, the color can add another dimension, if you like, or several dimensions, actually.
Yeah, I've used well. I think it's
indeed, really exactly, used well, as you said, because, you then run into problems. Color blindness, would people with color blindness still be distinguished what's happening in the plot?
Exactly, yeah. You don't want to exclude people as much as possible from your images, and you don't want it to be overwhelming. I think our stripes are perhaps a little bit too colourful, but yeah, it was a balance. The other thing that we really struggled with, so some of our stripe images are just this one single pale blue colour because there's no pollution. If you look at somewhere like, somewhere off the coast of New Zealand, it's beautifully clean. The levels of pollution are very, very low. So the entire plot is blue. Whereas other countries where, for example, Delhi, the entire plot is up in the reds. So it's hard to find a colour scale that works for such a range of different values. And some of our images, I think, work very well in terms of just being attractive images. And others, they're not that attractive because, they've got a constant level of pollution or something like that. If you were just looking at one city and you wanted an image just for one city, you would design a scale to fit that, to make that clearer. But because we needed a single scale for multiple cities, it does mean that visually work better than others. But I think that's the trade-off you have to make if you're going to use them to compare different cities. But it was important for us that every city was on the same scale so you could compare the different regions.
How many people were involved in the kind of user group that you used?
So there was quite a lot of people involved in the collaboration. So I think there's probably about 8 of us in the paper. And then we all pretty much asked around. So we probably asked about 30 people in total. And they ranged from, we asked public engagement experts, people that we've worked with at the universities through public engagement. We asked a lot of atmospheric scientists because the indicative levels, like good medium, they're not very well established within the community. So we check those with atmospheric scientists. And then we also asked kind of just friends and family, people that we know might be interested in it, but aren't experts in it, which I think was really important to get that input as well, to see whether it was clear.
You said that you would now prefer a more formal approach. Why is that?
I think it's just a very important step. And so I don't feel that we weren't systematic, particularly in who we asked. In terms of the researchers we asked, we kind of identified people we thought would give a really honest and useful feedback. So that's fine. But I've done a lot of kind of public engagement work. And if you're going to try and co-create something with a community, you want to be really clear about the community you're working with. And you want to make sure that you're also giving them credit in terms of how they're contributing to the. So if you're asking friends, you can kind of get away with it. But if you want to do a bigger project, then I think it would be advantageous to be a bit more systematic, to make sure that you're not missing parts of the community, that you're not, for example, we didn't ask many young people because I'm old. I don't know that many young people. So it would be great to have asked a few teenagers and things like that.
Right.
We're all biased in terms of who we spend time with and who we know. So I think it would have been great to widen that out. The other thing as well is we would love to work more with, a lot of the issues with air pollution. So there's this kind of good news story in the global north where you've got cleaner air. You've got this not so good news story in much of the global south, especially in Central Asia, where you've got really high levels of air pollution. And we just didn't have the capacity to kind of go and do a full engagement exercise with people living in those communities.
Yeah.
And that's something we'd love to do in the future, because we're trying to obviously raise the importance of, make sure that people understand and realize how important air pollution is, but also we'd like to speak to the people that are most affected by it. And that's very much something we'd like to do in the future.
So you've been involved in public engagement before, is what I'm hearing. What kind of tips can you give people when it comes to visualizing or turning data into a visual story?
I think have a look at what you like. There's lots of data science communities and visualization communities out there. Have a look. Have a look at what visualizations you think work really well, and think about why you feel that they work very well. So sometimes it's the simplicity, sometimes it's the message, sometimes there's kind of art almost embedded within it. And then also think about the data you have and the audience that you would like, and what level of engagement do you want these people to have with it? Do you want them to just engage very quickly? I mean, we let people come to our website, they look around, probably just spend a couple of minutes on it, so that's a fairly quick level of engagement. We're happy with that. But do you want them to have a deeper level of engagement? And then start to kind of think about what design elements would be needed for the different levels of engagement and to get people in. I think storytelling is massive in data visualization. The best data visualization in some way tells a story. And so think about what story your data is telling and how you might want to tell that. It's hard for us as scientists and data engineers and things like that. It's not natural, I don't think, to think about the storytelling element or the human impact element. But unless there's a story, I think people find it much harder to engage.
Let's say you do a presentation. Well, we would use a popular presentation tool from a big American company that we're not going to name, But anyway, so you can go absolutely wild with activities and popping in messages left, right, and center, including this, that, and the other. So you can actually overuse the tools that you get. Were you ever tempted by that? And how did you resist that?
Yeah, we were tempted more with the website interface. We were tempted to initially start with, to try and aim for something that was a bit more interactive and a bit more bells and whistles. Partly it was just limitation of funding and available time that we ended up with something quite simple.
Okay.
But I'm actually really pleased with what we ended up with. I mean, it is very simple, but it does not take any time to work out how to navigate it, if you see what I mean. Whereas I think often if you've got a funky interface, it can also be a bit confusing and a bit complex. So I'm quite pleased that we ended up simple. It was a pragmatic decision at the time, but I think it's worked quite well. I'm always a little bit suspicious of dashboards. Everybody likes a dashboard.
I was once called by a colleague of mine the Darth Vader of dashboards. Well, that's a thing of the past.
Oh God, I'm not alone. Yeah, I don't always know whether it's what a user wants or whether it's maybe more what the developer wants, because it looks cool and it's quite funky, but I don't know whether, sometimes I feel that they lack the storytelling or they lack the engagement element of it.
For those of you who went to the RSE conference in Newcastle last year, you may have seen the poster for yourself. As for the approach of getting complex data visualized, Kirsty mentioned a number of key elements I'd like to summarize. One is to simplify the data. If you have a large number of parameters and a complex field of data, Kirsty mentioned that they focused on a few key data points rather than showing it all. Simplifying it, she called it. Color also plays an important part in showing data effectively. But the choice of colors is important. In Kirsty's project, they looked at similar graphs to see if there is a common use of certain colors, like a color language. And also and finally, involving users and getting design feedback is essential. This kind of user interface testing is by now an established process for professional designers. And in terms of the Gestalt principles I discussed earlier, if you have seen the poster, you may recognize a few of them, like continuation or common region. Talking about Gestalt principles and a holistic approach to data visualization, for sure we need to look at the whole picture. But this is not to say that the details and components of a plot or diagram aren't important, quite the contrary. And there are some design approaches that help you come up with steps how you grow from basic elements or atomic elements to a comprehensive and holistic design for presenting data or indeed design entire websites. One of these approaches is called atomic design. And I had the great pleasure of talking to Brad Frost from Pittsburgh in the US about his book Atomic Design in an episode that will come out later this season. And we also have another ByteSized session on user interface design coming up next time with Meg Doherty and her team, so I hope to see you then. But before I leave, here are a couple of quiz questions if you have some spare time. So as usual, there are two questions, and the first is, in terms of optical illusion, there is something called the Necker cube, spelled Necker. What kind of illusion do you think the Necker cube shows? And when you look at it, can you actually reproduce it? And the second question is, if you look at a map online, what kind of Gestalt principles can you recognize? And that's it for this week. I hope you enjoyed the brief discussion on data visualization, and if you'd like to comment or have ideas or suggestions, don't be shy. You can contact me directly from your podcast app. The link is in the show notes, or you can reach me via email or LinkedIn, Mastodon, Blue Sky, or Slack, or Matrix. Next week is the last Tuesday in January, and as usual, it's time for a German language episode, and this time on a workshop on software competencies that happened last year in Hanover. So see you then. Thank you for listening to this episode of Code for Thought ByteSized. The content and the interactive ByteSized RSE sessions are created and run by Jeremy Cohen from Imperial College London and Steve Kraut from Southampton University. The podcast episodes are produced by Peter Schmidt. Finally, we'd like to thank Universe HPC for their continuous support. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.